So our next talk slot is actually going to be shared by two of our early career researchers. So the group, as Matt and Julia said at the beginning, have been doing an awful lot of work on various different aspects regarding variants of concern, trying to understand current trends, but also trying to understand what might happen if we get, say, for example, vaccine escape, and what implications this might have on things like the roadmap. So we've got two speakers, both of whom are, as I said, early career researchers, not co-Is on JUNIPER. We're very fortunate to have some really excellent early career researchers involved in the consortium. And so Ed Hill's going to kick us off to begin with. So he's going to do the first half of the talk. And I should say that Ed's talk is going to be recorded, but the second half of this talk by Rob Challen will not be being recorded and will not be being live streamed. So if anyone's joining us for live streaming, apologies, we'll be stopping after Ed Hill's talk. So Ed Hill's going to be talking about some work that they've been doing. So Ed's based at Warwick with Louise, Mike and Matt, and he's going to be speaking to you about some work that they've just been doing about looking at models for the impacts of potential variants of concern and possibly vaccine escape. So with that, I will pass over to Ed. Thanks, Ed.
Oops. Hi. Can we see the screen okay? And
yeah, we can
the
see
slides are moving.
Yeah, everything's moving. Everything's great. Thanks, Ed.
Okay, brilliant. Thank you. Okay. So yeah, I'm Ed Hill. I'm a postdoctoral researcher at the University of Warwick, and so this section of the talk is going to be looking at some mathematical modelling of illustrative examples of variants of concern. And so this is work being done with my colleagues at Warwick, as also in collaboration with colleagues at the University of Manchester. And so with our current situation, it's a number of different aspects and facets to the system. So there's multiple different variants. We have vaccination, there's the NPI policy, and then also adherence to those NPIs, just a few other factors involved. And so we can essentially use mathematical models to assess sensitivity to different parameter assumptions and convey the uncertainty given what we might consider plausible ranges for our parameters. And in terms of variants of concern, there might be two different ways that they could be concerning. That being, they could be more transmissible than the currently predominantly circulating variant in the community, which we'll refer to as like the wild type variant. And also possibly if they evade immunity, whether that be to immunity derived from prior infection or immunity derived from vaccination. And in this bottom table, we're just going to present some illustrative examples for different scenarios for a novel variant of concern. So we might have a more transmissible variant, which will enable VOC-MT. That is like 1.5 times more transmissible than the pre-existing wild type, but it doesn't have any immune escape properties. So any prior immunity derived from vaccination or from previous infection by the wild type is just as efficacious against the variant of concern. And then we have an immune escape scenario where the transmissibility is the same as the wild type, but now the pre-existing immunity is less protective against the VOC. And final consideration might be you could have a VOC which is less transmissible, but still has some immune escape properties to investigate what might be some potential dynamics from such a scenario. And so we're going to do a very quick overview of basically 3 different research directions that we're looking at. One using a non-age structured deterministic compartmental model with homogeneous mixing to get some general principles from sensitivity to this system. And then a brief overview of a age-structured model that includes a kind of severity or burden model, so we can also then track, say, hospitalizations. And then finally, in the case of a VOC emerging that has immune escape properties, and the prospects of potentially having new or updated vaccines that target the VOC. How does the timing of the introduction of this VOC-targeted vaccine relative to the VOC emerging impact the future temporal profiles of infection? So to begin with our, say, non-age structured compartmental model to capture two different variants, one being the variant of concern and one being the pre-existing wild type. So we're going to step through this set of dynamics. So we essentially assume an SEIR type framework, so susceptible, latent, infectious, and recovered. And so now in this top highlighted box corresponds to infection with the variant of concern and transitioning through the E, I, and R states. Going in the other direction corresponds to infection with the wild type. And we make an assumption that it's not possible to have co-infection, so you can't be infected with the wild type and the variant of concern simultaneously, which therefore means after a first infection with either of the two variants, it's then possible after that to potentially become infected with the other variants. And then after that, you then transition to this RR state where you're now recovered from both. So whether it's permissible or possible to be infected by the other variants post your first infection depends on the immunity assumptions that we have. So that gives a broad overview of the system. And so this corresponds to, say, just unvaccinated individuals. We can essentially copy this into, say, multiple different boxes to correspond to the different number of vaccines that might be in use. And in our case, so we've got the mRNA vaccine, so the Pfizer and Moderna. We've got the AZ vaccine. And we could also consider this, say, updated or new vaccine that targets a variant of concern. So therefore, we've essentially just like duplicated our base system to have another dimension to capture different effectiveness of the various vaccine products that are available. So we took this model and we did some exploratory simulations for a population corresponding to roughly the size of England, and say beginning from the 10th of May, running for a year, with then 1,000 infected individuals introduced into the system on the 1st of June. And within this, we also capture changes in the level of MPIs and how that corresponds to this measure for our excluding immunity. And then also vaccination increasing over time. And in this system, we're purely focusing on infection. So there's no, say, burden model. So there's no mapping to, say, hospitalizations or deaths in this instance. So our, say, example output. So what we depict currently in this top panel is to showcase what's happening with our vaccination uptake over time. And then also with, so that's the shaded blue region. And then the dotted profile is to show our excluding immunity profile and how that increases over time as we progress through the steps of the roadmap. And so these increases correspond to the earliest dates each step might take place. So this initial jump up here is basically corresponds to today, so the 17th of May. And this later step up is then moving to step 4 at the earliest, currently on the 21st of June. And what we have in the bottom panel is the temporal profiles we get for infectious prevalence for our 3 different VOC scenarios. And what we see with the more transmissible scenario, so with the square markers, and with the immune escape scenario, so the plus sign marker line, in these 2 novel variants, we can see can lead to waves of infection beyond what we might expect from the pre-existing wild type, with no variants of concern being introduced into the system. And it also exceeds, say, the estimated prevalence from the January 2021 wave of infection, which in England, estimates from the ONS study put that about 2% prevalence. And we also see with our less transmissible, but including immune escape scenario, we get a more delayed epidemic, but there's still some increase in infection that might occur, even though that variant of concern is less transmissible than the pre-existing wild type. And then expanding this out, we can then explore the parameter space a bit more broadly to consider a broader range of transmissibility values of the variant of concern compared to the wild type, and a wider range of immune escape properties from the y-axis, where 1 corresponds to the immunity derived from prior infection with the wild type and the vaccines being just as protective against the variant of concern, with then decreasing proportional efficacies down to 0.5, and with the labels, lettered labeling corresponding to our 3 Vox scenarios of interest. But the broad principles we can discern from this, perhaps unsurprisingly, as we get a more transmissible variant, and that has greater immune escape properties, so there's less protection from previous immunity. We enter the bottom region of our heat maps, which have a much higher final size, a much greater peak height, and the peak timing also occurs much sooner, with the peak timing becoming more and more delayed as the transmissibility is reduced. So that's like a broad overview of our non-age structured model. So a couple of slides on our age structured model. So this builds upon so the model that Mike presented in an earlier talk. And so this includes the 2-dose vaccination schedule, as well as the different age bands, and has the mapping to severity of case outcomes, such as hospitalizations, ICUs, and deaths. And the main point to make here is that even though vaccines can be protective against severe infection and severe case outcomes, given the number of infections could still be high, the number of hospitalizations could potentially still also be high for a variant of concern that has certain properties. And so in this example, we're just showing different assumptions for a more transmissible variant that could potentially lead to very large waves of hospital admissions in a resultant wave of infection. And the second aspect we might be interested in using the age structure model is to get some perhaps early signals of what attributes the variant of concern might have. And so in this example plot, the solid filled in bars, so the black shaded bars correspond to the pre-existing wild type, which might have the proportion of infection split as 80% in the unvaccinated and 20% in the vaccinated. But then when a variant of concern is introduced, we might see a shift in the relative amount of infection split across the 2 groups. And so the thinking is, if we see a shift where there's now the proportion of infection is now even more greatly skewed towards the unvaccinated, that might suggest a more transmissible variant. Whereas if we see a skew in infection back towards the vaccinated individuals, that might indicate a variant of concern with immune escape. And therefore, we might translate that to looking at the age distribution of cases, given the vaccination program being predominantly based on age. That might give us some insight as to if a variant of concern, if a new variant is being identified and we see a change in the profile of who's getting infected, it could tell us something about the properties of the variant of concern. Cool. And the last couple of minutes, just a quick example from introducing a new variant of concern targeted vaccine and how the timing of that might alter the infection dynamics. And what we see here is, in this setup, we now have a variant of concern introduced from the 1st of August. and a new vaccine introduced on either the 1st of June, the 1st of August, or the 1st of October. And again, perhaps unsurprisingly, the earlier we introduce the vaccine relative to the introduction of the variant of concern, we get a reduction in the size of the peak of infection, and it's also slightly delayed compared to a later introduction of the vaccine compared to the variant of concern reaching, say, 1,000 cases. Cool. And yeah, and again, we're doing some exploratory analysis for different variant of concern assumptions. But I'll just finish off there so we can swap over to Rob. But our broad summary is these novel variants can lead to waves of infection beyond what we might expect from the wild type. And it's possible for waves of infection to be caused even by variant of concerns that are not as transmissible as the wild type if they do have some immune escape property. Great, and yep, so just thanks again to everyone here at Warwick and our collaborators at Manchester, and to everyone in the JUNIPER consortium. And with that, I will now stop sharing and pass over to Rob.
Great, thanks very much, Ed. And just to say, we'll take questions for all of this right at the end. So Arnell, if you could stop recording and live streaming, please.